The Breathtaking Ice Formations is the title they gave me. I also use another one. It's covering up something here. Ice flowers, needle ice, pebble ice, and hair ice as products of ice segregation. Right, coming down here, click. Where am I here? There we go. It all begins December 20, 2003. I go hiking at Big Ridge State Park in East Tennessee. I found interesting forms of ice. I took a couple of photos with my new digital camera. Here's one of the photos I got of a piece of ice. You can see its size by the leaves. Another photo, and on this one you can see the ice had been higher here and it slid down. I must confess I took no observations about this place. I know not where it was in the park. I knew nothing else. I just have these two photos. What is this? Never saw anything like it. That fall, I was showing my photos to the Illinois State climatologist. He said, why don't you send them to me? I'll ask about it. I said, no, I think I'll put them on the web. Created a web page. You already had a web page. Posted them on the web. Started looking around. Called ice flowers, frost flowers, ice ribbons, rabbit ice. Been seen Missouri, Arkansas, Texas, and Florida. Went back to Tennessee the next winter. And lo and behold, I found some new ice. But this ice was on this tall, one single stem, growing out from the stem. Another photo. The pen gives you a scale. And you can see that the ice seemed to have slid down the stem. I searched the web for what might be out there. I found Bruce Means in Florida had written 6 articles about such ice flowers on the same plant, Verbesina virginica, white crownbeard. His first article was 1985. So I wasn't the first. Got an email from Charles Knight, National Center for Atmospheric Research, and he told me the process is called ice segregation. He's never seen it. He would like to have, but he identified the process. He cites an article by 2 Japanese scientists who grew ice in a lab. I got a copy of that article. I didn't know enough at the time to understand how ice segregation applied. Someone sent me reference to a photo of ice on the cover of an academic journal. Photos in the Himalayas of India, about 16,000 feet. I found the journal, got a copy of the photo, and I've since been in correspondence with the person that took that photo. A couple of years later, I get an email from Thomas, who puts out a site called the Contemporary Nomad. He has 5 photos of an ice flower on the Himalayas in India. And here's one of it. Here's his website. I think this site is still up. And there's the ice flower. Very similar to what I'd seen in Tennessee that second year. Beautiful. What plants do they grow? Where can I find those plants? What kind of weather is needed? I had a bunch of questions. I went to Illinois, and I planned my visits to my daughters in Virginia and Tennessee during possible ice times. Mid-November 2005, go to southern Indiana. Stayed at Frost at Whitney Falls State Park and woke up to a frosty morning along the Ohio River. This was our image of the Ohio River looking off to the east. That's Kentucky across the river. And the temperature seemed to be right. There was a large amount of frost throughout Whitney Falls State Park, but I couldn't find any ice flowers. Drove into Kentucky, small white patches along the highway, got excited. The first stop turned out to be plastic bags. And then I stopped at this place. And look at this over here, this white at the side. Looks like plastic bags. Looking a little closer, that's ice. Closer yet, there's what I'm looking for, my ice flowers. Cut off stems at the side have been mowed. And here's the ice flowers. And there's about my favorite one. You see the cut off stems here? That's the ice. There are some dried up leaves from the fall. And here are some weeds in here. And we see tinges of frost on the edges of the weeds. Very informative photo right there. We picked up some of that ice, and the pieces of ice just fell off the stems. It wasn't embedded in the stems at all. So I come back and look at this. This is the environment in which it occurs. We got free water here. It's a cold morning. We have frost, but it's not extremely cold. People often tell me, like, oh, boy, it's 0 out there. You must love this. No, when it gets to be 0, everything is frozen. You're not going to see any ice flowers. As we drove south, we saw ice flowers off and on for the next 50 miles. It told me that they're not all that exotic. The plant is white crownbeard, Verbesina virginica. This is the plant Means saw in Florida, and I saw in Tennessee in 2004. I didn't know it at that time. There are other Verbesinas, all with yellow flowers. Some occur around here in Virginia. but we believe only the white one produces the ice. So I come to central Virginia, a day after rainy Thanksgiving, cold morning, I think it was about 23 according to the weather forecast. I visited the Amelia Wildlife Management Area. It's about 30 miles west of Richmond. I found ice formations along a cover area. Here was the farm field to the left, where there had been a road, walked in there, and here is another ice flower on the stem. Never saw anything like that one. It's quite unique, not like I've seen elsewhere. I think the plant, I still haven't identified, I think the plant was a bone set, and the ice had ruptured the stem. And beside it, here is needle ice. You see little cavities here in the soil. That's needle ice. Those cavities, I reach over and pick up a piece of that ice, turn it upside down. Needle ice. Ice grows up from the soil. It's quite common. We know how it forms. The air temperature is below freezing, while the water in the ground is still liquid. And there I am holding the piece of the topsoil upside down. You can see the needles that are growing up from the soil. And then I saw this little column of ice over here, clear white column, well, I should say clear ice. The pen gives you some indication of it. Didn't know what that was. Picked up the ice, put it in a plastic bag. In an hour, I had a puddle of water in the bag. And that's all I got out of that. But keep that in mind. A lot of clear ice, not needle ice, not lifted any soil. I didn't see what was growing. So there's my needle ice right in here. And look at this little plant right there. This poor plant was laying flat on the ground. The needles grew up, lifted up the leaves of the plant. In a couple hours, it'll warm up. The ice will melt, the plant will be back down on the ground again. I have some other images of needle ice. If you're familiar with it, a colleague of mine got this one from Missouri, and you see how it lifts up particles of soil. The pen gives you a scale. This is some needle ice next to my apartment here in the Richmond area, Midlothian area. We'll come back to that. There's some ice from Knoxville area, Tennessee. The pen gives you a sense of scale, and you see the pieces of dirt or soil, rocks that have been lifted up by this needle ice. Woman sent me this photo. This photo was taken in a volcanic island, the island of Réunion, 21 degrees south in the Indian Ocean. So it need not be just here in North America. And this is needle ice from the Rollisons couple along the Appalachian Trail in southwestern Virginia. And the idea of needle ice gave me another term to search on. Because I was an academic. I found Lohr in 1980 to publish a bibliography of needle ice. That bibliography had 267 items going back to the 1800s, and some of those linked related to ice flowers. I dug into that bibliography, and I wrote a summary of the relevant articles and posted those on my website. A couple of things of note. Herschel, 1833, wrote in Philosophical Magazine on a notice of a remarkable deposition of ice around the decaying stems of vegetables during frost. That's ice flowers, 1833. 1914, Koblitz wrote the article on the exudation of ice from stems of plants. He found a plant called Dittany. And Dittany was a plant I found that first time, and I didn't know it at this point. He found Dittany in Rock Creek Park in D.C. And he grew ice and cut off stems. He's able to grow that ice in test tubes in the lab and found the roots were not required. So where can I find examples? I searched widely trying to find it. Got up every cold morning, ran around trying to find ice flowers. Didn't find any in 2006, but I did find some seeds of that Verbesina virginica, white crownbeard in Tennessee. I planted those in my yard in Illinois. And next summer, 2007, this is what I had in my yard. I had ice flowers this white crownbeard in these two black buckets, and I had ice between the two buckets. The rest of the green is ornamental material. I had ice flowers in my yard, ice plants. November 7th, my first ice. And here it is in my black bucket. Look at this ice in here extending well up, 2-3 feet up the stem, curling around the stem. And on salvia, we expected to see the ice in the tall plants. My wife came out and looked and said, "What's that white in the flower bed?" We had ice on salvia. Surprise. Had we had ice flowers in our yard for years but never looked? Probably. And here's the salvia in our yard. Ice on that salvia. Here's some more salvia over here. And I'll come back to talk salvia later, but we had ice on salvia to our surprise. And here, coming back to the ice in the buckets, these ice flowers, and this is on Verbesina virginica, white crownberry. How fast does this grow? I had all kinds of questions. So I saw it forming one night, so I set the alarm, got my camera and flashlight. There's the ice at 12:15 in the morning, 2:45 a.m., and 6:40, and it confirmed that ice grows quite systematically. It's not explosive. What you'll do in the name of science. So I'll come back and look at some more of that ice in 2007. We had ice 20 times that fall. First seen November 7th, last seen January 9th. The place where the ice grew on the stem moved down on the stem through the season. By the end, we had very small formations. But I was surprised most of the stems did not rupture. So here's some of the ice. And you see how that ice often peels back the bark. And here towards the end of the season, here we see a little rupture in this stem, but these stems here haven't been ruptured. Had more ice. Fall 2008, planted the white crownberry in the buckets, in open grassy areas. I had 3 varieties of salvia in the garden, and many other garden flowers. First ice on October 28, but only in one place, a unique microenvironment. There is where the ice is. You see the ice? It's right down here at the bottom. These 2 little white spots are the ice. Look at them close up. There is the ice. Little piece of about 2 inches long, 5 centimeters long, that ice. There's one of the little ice flowers. There's the other. I monitored this site very heavily that morning with all kinds of temperature probes what I could get. There was no breeze. Those little cut-off stems radiated to the clear night sky. The temperature fell to the frost point in only a couple places. And the only other ice I could find that morning was on the windshield of a nearby car. Got cold enough to produce some frost, but that was it. So there's those 2 little ice flowers. Very small, unique environment. But I learned from that one. Then November 9th, the season started in full. I found ice frequently. Sometimes ice formations carried over to the next day. One of my examples, here's the one that was on the cover. And this one. These are the 2 images of the same plant. We look down on this, you can see how the ice radiates from all around the stem. And as that ice comes out, sometimes it gets captured. One blade captures another and it gets wrapped around. This is the side of the stem, side view. That's this view right here. And you can see the stem as it's swept around. It takes some very interesting forms. This is the same plant, but this was late at night, the next night. During the day, the ice had fallen off, and this was the ice that fell off the side of that. And now we have freezing taking place again, and new ice is growing up on that stem. So, looks a transition. I put this slide in, not because it's pretty, because it tells us what it often looks like. It's not plenty of ice on the stems, but you got the old leaves on the plant that are dying, you got leaves in the yard. So it isn't always nice and pretty, like the few shots that I include in this presentation. This is a piece of ice that I find very interesting. It was a scoop, and I got a close-up of it, and here's an even closer view. And you note here, see the blades of ice coming out of the stem. And this blade right over here is pulled away from the stem. Very similar to what I saw in Kentucky, where that ice just broke off in big pieces. So this is telling us this is not splitting the stem. You really don't see any cracks in the stem as to where that ice comes from. I included this one in there because it's one of those pieces of that Verbesina. And the ice comes out. Surely you've seen something like this. We call it ribbon candy. And I put this photo in. This was between the buckets. And this was beautiful sun shining through this bunch of ice, cluster of ice. And remember this photo. We'll see it again. And I zoomed in on the photo. We got some very interesting textures from that. And zoom even one step further, and I don't know whether you see this, but this is the background of all my slides. It comes from this photograph, zoom in even further, and that's the background of all my slides. Now, ice on salvia. I had a couple varieties of salvia in the yard. The red, rather inexpensive plants. They sell for about 4 plants for $2. And then I had some on Victoria Blue, a more expensive variety of salvia. There's my red salvia, considerable quantity. Now here's an example of ice on a salvia stem. Really nice. And this one, if you know your plants, there's the little flowering bud heads of salvia. Some interesting displays. But I had Victoria Blue salvia in the yard. I didn't have any ice on it until December 28th, 6 weeks after the ice on the other salvia, and after the ground had been frozen and then thawed. And here is my Victoria Blue salvia. I had some of it scattered amongst a little rock garden. And there's my ice on salvia. Very small, very interesting. And this one, I've never seen one quite like that with a little 4 petals of ice. Only a couple inches across, but gosh, quite nice. And here's another one on Victoria Blue salvia. Not from that time. This was in a mid-November period. And the ice formed just as I still had some display of flowers on the plant for my Victoria Blue salvia. Lovely photo. I'm going to recommend that you look at the YouTube video of the growth and decay of a frost flower by Dr. Forrest Mims. There's a lot of other YouTube videos out there on frost flowers, but this one's head and shoulders amongst the rest. His video shows the growth and decay of a white crown there, Verbesina virginica. I want you to note the ice does not split the stem, but it does peel back the bark, and he calls these frost flowers. And so here's his site, and there's an example. He took this at night because you can see the black background, and as you click through it, actually play through, you see how it changes shape. And he shows that after sunrise, the frost flowers return to the soil, and you see it fall off, as we've seen. I highly recommend this. I watch this occasionally. It reminds me of what I'm looking at. So, at this point, any comments, questions?
Hello. I guess my question would be is why does the ice grow, and I might have missed some of this, but why does ice grow on certain types of plants and not others? Like what is the makeup of the plant that allows for the growth of the icicles on some and not others?
That's a very good question, and I wish I knew the answer to that. I spent a lot of time trying to figure that out, and I haven't figured it out. I will make a little comment on it later, but I don't have a good answer for that.
Thank you.
Next thing comes along is I have hair ice on dead branches. I got an email from Jeff in Wales with photos asking about ice on dead wood. These weren't ice flowers, but they're quite attractive. And posted his photos on my website. These are a couple photos from Jeff on a piece of dead wood. And then Joaquin in Sweden found ice in Germany, and he sent me a copy of this called Hair Ice. Rick in Vancouver, British Columbia, and Bobby in the Olympic Peninsula, Washington, sent photos of ice on dead branches. Now we're in America, the United States, and people had written about these in the 1800s. Somebody was able to bring branches in and grow ice. I found that in that bibliography I had. There's Bobby's photo of ice on a dead branch. And then Gerhard Wagner, Dr. Wagner contacts me. He was in the mid-80s when we started dealing with this. The last time I corresponded with him, he told me he's about to turn 99, or is 99, turning 100. He saw my webpage, he contacted me. We've been corresponding quite regularly. He calls this hair ice. You remember hair ice? It's related to a fungus. And he has this page up that here's his hair ice on pieces of wood that have that fungus. And if he treats them with a fungicide, it suppresses the growth of the ice. We continue to work in that regard. Now, the fungus is not found where we live, so we don't see it around here in Virginia. Dr. Wagner contends it's found north of 45 degrees. That's the latitude of the Great Lakes, Boston, northern Italy. Then I get some photos sent to me of ice on rocks. Jerry in Alabama sent photos showing ice on rocks. I didn't understand those. And Jared in Missouri had photos on ice rocks showing ice from pebbles, the only examples I know about. Well, that's what Jerry sent me. Okay, don't know what it is. Jared sent me from Missouri, angular rocks. And lo and behold, I look at this rock. This is a pebble right there, a rock. And that ice is on that pebble. And that ice is related to that pebble. I see nothing else involved in that other than that pebble. That caught my attention. And remember that ice rod I had in Virginia? I pointed out the needle ice, similar to this type of ice. I never thought about looking for an underlying rock. There's that straight rod of ice out of the ground. I had no idea what it was. I think it related to this ice we see here. So I had them send those rocks to me. Round rocks from Alabama, more angular rocks from Missouri. I put them in an area of needle ice in my yard. Well, here, right beside my porch, I had this patch of needle ice. This is the ice at 9 o'clock in the morning. And one day, I get this needles. I can put a penny in there, the penny stands up in these little grooves of needles. 2:30 in the afternoon, the temperature warms up, the ice melts, turns to mud, the penny falls over. That's needle ice. I took those rocks that I had from Jerry and put them in that mud, if you will. The next morning here, I had ice growing on these rocks. It worked. Had ice on those rocks right out my door. I call that pebble ice. There's a piece of pebble ice. So I had 4 different types of ice formations on different media. Ice ribbons and flowers on the stems, needle ice from the soil, hair ice and dead branches, and ice growing out of rocks. They all form under similar weather conditions or natural. I turned to Weatherwise and worked with the editor, and we created an article on unusual ice formations, studying the natural growth of ice from soil, stems, branches, and rocks. The first issue of 2009, showing some of those photos. So, we've established the 4 types of ice occur by the same medium. Ice segregation is the process. Supercool water moves to the ice, adds to the ice. It's been demonstrated at a lab in Japan under controlled conditions. And frost is involved to provide the ice to start the process. Any questions or comments at this point?
Yes, Dr. Carter, we do have a question here in the chat. So if the stems in your 2007 buckets had been cut shorter, would the flowers have been more horizontal or more looping?
I don't know the answer to that because I've tried a lot of different ways to cut the stems at different times, and I don't know that I can make that. It does have some impact as to where you cut the stems, yes, but I'm not certain I could tell you the answer to that.
Okay, any other questions?
Okay, so let's come back then to that patch of needle ice and the pebbles. I noticed the ice doesn't melt entirely during the day in some cases. There was that pebble that I had where the ground is frozen. By mid-afternoon, the ground had warmed up and the ice was still on the pebble. The next morning, we had new ice from below and ice on top, and that afternoon, the ground had melted, but I now have 2 days of ice on that pebble. So what I have here is day 1, morning, afternoon, I have the same ice growing over a 2-day period on the same pebble. I can see the break between the melting and freezing. And finding that explains the needle ice in a photo from Southwest Virginia. This is the photo I showed before of needle ice from the Rollisons. And here's another part of that same photo they had. And here we see moss along the trail. And here's needles here with a break between them. What we have here, my interpretation is, this is the needle ice from the first night. As the needles formed, it pushed up the soil. It has mud at the top of the soil here. And by midday, the ice quit growing. There was a break in the ice. Some of the ice probably melted at the bottom. The next night, new ice formed coming up out of the soil. There's mud at the top of the soil, and that's the mud, or that's the needles from day 2's of ice. And now we're taking this photograph during the warmth of the day. We don't see the needles down here at the bottom. They probably melted. And is it possible that ice would form the 3rd night and push this up even higher? This photo's gotten quite a bit of recognition, by the way, and that's my interpretation of it helped them get that pushed around. So there's my question. 2 days of needle ice, day 1, day 2, older ice at the top. Will there be new ice the next night? Good question. So I'm sitting there in Illinois, and occasionally I get those days when it's warm in the day and I can get, I see mud at night, I get ice. So when I go into winter, there's a way I can grow ice in the very cold days. I need something warm to keep my pebbles warm. So I put together this little device in an ice chest with a heat source, and by golly, it worked, because there I've got out there in my deck, I've got some ice on top of these pebbles. It worked. Now, could I duplicate that in a freezer? 1914, Colwitz grew ice in Dittany in a lab in DC. I had a refrigerator with ice in the geography department at Illinois State University. So I go up and take over the refrigerator, the freezer part, and here's my little ice chest set up there with my temperature, remote temperature controls. And I put it together like this. Inside the box, my little cooler, I have a heat source, being a Christmas light, Christmas tree light with a rheostat on it I can adjust. Covered that over, laid a big sheet of aluminum over this to disperse the heat. Put another box in, packed insulation around it, and I get ice going inside my little bucket. The question is, what do I use for a medium, sand versus soil? I want something to hold the pebbles and be able to transmit the water to the pebbles. One time I put some soil in there and I get needle ice out of the soil. And you see here, good illustration of needle ice. Some of the needles push up and leave gaps underneath here. It brings a lot of mud with it, quite messy to say the least, but that's a good example of needle ice. But that illustrates something I'm going to point out, the difference between needle ice and pebble ice. This is a good example of needle ice. From a place around Knoxville, we see the needles come up from the soil and push up all these rocks, a number of rocks in here. And at the bottom of the needles, it's quite ragged in here. Many of the needles ran out of moisture, and only a few little strands of ice continue to push the rest of it up. That's a good example of needle ice. And here in that same place, we see some other needle ice. This is needle ice, and there's a patch of needle ice, but that's fallen over on its side. And here we have a good example of pebble ice, because this little pebble right there, that ice grew up from there. That's clear ice out of that pebble. We see a pebble right here. We see ice is growing up here. We see another one over there, pebble ice. So I make a distinction. The soil, the needles lift the soil and anything overhead. Sometimes the soil becomes depleted of water and only a few needles prevail at the bottom. On pebbles, the water moves through the pebble and produces clear ice. It's not ragged at the bottom. Here's a good example of pebble ice. Little bitty pebble here, and look at the beautiful ice. And there's another example there of pebble ice. So I use sand in my bucket as the holding medium because it was very porous. It does not produce needles in the soil. I must confess, sometimes the sand grains are lifted to the top of the pebble. So here's some of the examples of what I was able to grow in the refrigerator. This beautiful angel wings, if you will. And notice along here these striations. What in the world are those? When we got a temperature probe recording thermometer, we found out that's when the refrigerator or the freezer cycles on and off, and it leaves these little ridges in the ice. It's that sensitive to the variation in temperature in the freezer. I played around with some things. Here's an example. Good ice. I had one pebble laying on top of another. It actually lifted the pebble up. Well, sometimes we got ice, sometimes we didn't. We've got a lot of different examples. I used bricks sometimes. I had a couple bricks I found worked quite well, just like they were pebbles. They had the proper porosity to prevent this. Here's one of my better examples. A nice little pebble that smooth on the top, and the grains under the sand grain were lifted up as the ice grew up from the pebble. I lift the pebble up and look at it. So here we are. Here's our pebble, and the water comes through the pebble, forms ice, grows up, and goes over here in that pebble. Well, seeing that gives me the ability to diagram of what we're looking at. Have the bucket. This is my sand, the yellow. We have the water level in the sand. This is my pebble. We need the air temperature here to be above freezing and the temperature up here to be below freezing. And then there's enough frost in the refrigerator that we can go lack of frost to initiate the process. And we get pebble ice growing on the side of the pebble. So this is the diagram. You see that diagram? It's very similar. Look back at this example here. That pebble, and here's the pebble. The water comes through the pebble up here. It hits the cold air, forms the ice, and it goes through the pebble over to here. That diagram. And I got some pretty interesting ice of some of this. Again, you see the little striations in there for temperature. Here's one of the better ones I picked out. It's my fingers holding a piece of ice on a pebble. It's a pebble from Jerry in Alabama. One of the limitations on this is you just plain run out of water. There's only so much water you can hold in the bucket. I don't know how long you'd go if I had a good source of water. This example, this one pebble, illustrates many things. There was a pebble, a nice pebble, we've used it many times. And this day, here's the ice, the old ice up here, the pebbles, the ice is coming through the pebble, grows ice up here. And for some reason, the pebble split. And the ice, as it continued to grow, split the pebble. So here we are as it warmed up. Here was the top of the pebble, it got split by the ice. Now I have two pebbles, half the size they had before. But that's a geomorphic process, and this is what takes place in nature. Such ice does break down a lot of rock and break up things in nature. So I've learned a lot from those experiments in the lab. Thousands of photos, look at the same pebbles time and time again, and I gain an understanding of ice segregation. How do I figure out which pebbles to use? I develop many tests to see which pebbles are likely to produce ice. Never developed a foolproof test. I'll use the tongue test sometimes. Earth scientists know that sometimes you taste rocks or touch them to your tongue, and if a pebble tends to stick to your tongue because it wicks up the moisture, there's a good chance that pebble might produce ice. But I found even the most productive pebbles did not produce ice every time. Get ice, beautiful ice one time, and it may take a month or two to get that same pebble to produce ice again. Now, if that works with pebbles, will it work with plant stems? After many years, I tried that, yes. Sometimes I had good success, sometimes not. So here's my plant. There's my Verbesina Virginia, white crown there. There's a plant called Penta. I'll talk about that later. But that's in my freezer, and there's the ice that it produced in the freezer. There I am holding the stick of Penta. So I've got a cut-off stem in sand, in a freezer, and I grow ice flowers on that stem. So what plants produce ice flowers? I corresponded with a number of people, Mary Ellis in Arkansas, shared many things, Jan in South Carolina, Bob in Texas, Carl in New York, and many more. We have the Verbesina collection. Many varieties of Verbesina. The white variety produces abundant ice. The three yellow varieties, never found ice on any of it. I've concluded only the white produces ice flowers, probably. Not a very definitive answer. We think it doesn't produce any. The yellows, only the white produces ice, probably. So here I am standing next to some very older versions of Verbesina. This one's the white here. This, I think, is the yellow flower here. Very hard to tell apart. The white does produce pretty blossoms, and they are very attractive to bees, bugs, and butterflies late in the season. And here's my stand in my yard in Illinois. Shows you the height of some of these plants, getting ready for the cold season. I cut some of them back at different heights. Here I'm standing beside it. For scale, remember a brick is 8 inches long. And I get a variety of different types, showing some of the better examples. This was not a complete growth, got interrupted, but beautiful little bottle brush type of ice flower. Sometimes you get down on the ground to take photos like this one of another ice flower on Verbesina. Some examples. Very difficult to say what the ice is going to look like on any given day. Well, this one interesting, the bramble double ice. This was a split stem, but to think of anything different that day, you look back here, here's another ice flower back there looking very consistent with the others we've seen. And then there's this plant called Dittany. This is the plant that I saw when I was in Tennessee. The first time I found my ice was on Dittany. Dittany is a low-growing bush, multi-stem plant, small leaves, pretty purple flowers, multi-branch, and some of these stems you'll see are shattered, but interesting ice on it. And it too can produce this ribbon candy type of thing in the right situation. And then I found that late winter, early spring, I was seeing ice on some Dittany stems while new growth was emerging from the ground. Really interesting. So I think it's worth noting, Dittany, the canoa organolis, and the white-crowned Verbesina virginica. These are the two Native American plants known for producing ice flowers, frost flowers. There are a few others around, very rarely seen, very rarely reported on. So these are the two plants, quite different. One tall, single stem, one low-growing, bushy plant. The two plants, Native American plants that produce ice flowers. In my yard, I also had a plant called Penta. I have a bunch of Penta in my yard now. It costs about $4 for a nice plant. I see them around a lot of places. And lo and behold, my Penta produced good ice, to my surprise. So I've been saving it, growing it, because it's pretty, and two, because it produces nice ice. A fellow in New York sent me a note. He said, if you look at this Japonica, he's got Japonica. That's the tall white flower here with the blossoms. I think this must be the plant. I've seen photos from Japan showing ice flowers and plants. This must be from that plant. This was a very bushy, single cluster of stems, quite abundant ice on the Japonica. It doesn't seem to last long. It's only early in the season, doesn't seem to carry well. But I bought that plant and had it in my yard. And so you start looking elsewhere. Where might you find ice? I've seen it on marigolds, right here on the coast. Not very pretty, but a little ice on marigolds. On lantana. And the lantana, it doesn't occur at the ground. It may be higher up on the stem. So, we know ice flowers occur on far more than white-crowned bird and Dittany. Many garden plants produce ice on occasion. Sometimes not very, sometimes very little. In 2014, I posted a list of plants on which people have found ice. Now that listing is fairly dated now, but there's a great number of plants that people have reported finding ice. It's still up on my website. I know sometimes it occurs far up the stem, not necessarily ground level. And one reflect on what we know more about hair ice on pieces of wood. You know, fungi is involved. There's good research on the topic in Europe. I've gotten many good photos of hair ice. Here's an article some of my colleagues are working on, Enlightening the Mystery of Hair Ice. The first two authors are from Switzerland, the other two authors are from Germany. And they're producing some good work on hair ice. And hair ice in North America, I've received emails from persons in the Pacific Northwest of Canada, US, and then recently I've gotten photos from Ontario, Nova Scotia, Newfoundland, and the eastern part of Canada. And here's some Sybil in Halifax, Nova Scotia, some examples of hair ice on dead wood. And this one's interesting because it's well off the ground. Beautiful piece of ice. Sybil. And in that original bibliography I found, reference was made to Livy, who wrote about ice ribbons on Dittany in the Appalachians. She was at Crater Lake National Park. But Dittany doesn't grow in that area. And I now realize, I went back and reread her description, she was describing hair ice and made the association that hair ice in the Pacific Northwest looks a whole lot like the Dittany she saw in the Appalachians in her youth. And there are YouTube videos on time-lapse videos showing the growth of hair ice. And we'll look at those. My ice flower has been recognized. 2013, the American scientists contacted me and wanted to do a study of my ice flowers. Okay, worked with them on that. Many of my photos were not high resolution. I used my small camera to take those photos, but we worked with it. The issue came out, and lo and behold, there was my photo on the cover of the American Scientist magazine, much to my surprise. Yeah, so in that article, they had photos of needle ice, pebble ice in a freezer, hair ice on pieces of wood, and ice segregation was identified as the process common to it. I worked with the editors to produce the article, wrote the article. Then the French contacted me. They wanted to do a reprint of my article. You can't do that. I contacted the Emeritus scientists. They said, oh yeah, we do it all the time. So the French came up with an article. And you recognize this photo on the front, the flowers of ice. And there's my photo again, the one that was between the buckets. They photoshopped it, didn't include anything else, and put it on the front. But there's the article about ice in French. The Germans contacted me. They want to do a reprint of the article. And I noted that I've been corresponding with some people in Switzerland and Germany about ice. And so we found people there that had some ice flowers and included those in the article. So there's the article in Spectrum, the article in German. And here are a couple of photos from Germany showing ice from people in Germany looking at ice flowers. Then I found a Spanish version came out. I wasn't aware it was coming, pleasantly surprised to find out that it was being produced. And lo and behold, on their title page, there's that photo again of my ice between the buckets as their title page. Flowers and ribbons of ice. So where I live in Virginia now, was in Illinois, how do I get to see her ice living so far south? Well, a fellow in Western Washington wrote to me and thanked me for the explanation for the ice he'd been observing for 30 years. He didn't understand it. I gave him the answer. He sent me a box of wood known to produce hair ice. And there's one of those pieces of wood that he sent me. Hair ice. I was quite surprised that hair ice, which is supposed to be based on that fungus, had survived for at least 3 years and stored the wood inside. And there I'm still getting ice on hair ice. Now where do I find ice segregation? Well, I moved to Virginia in 2017, and I found needle ice near my apartment. Let's go for it. There's the needle ice, the soil close to my apartment. I took advantage of that soil to produce needle ice. I planted what was left over flowers from summer, pentas and salvias. I used the pebbles and sticks I brought with me that should produce ice. And so there's my penta. There's some ice on salvia. This was in mid-January. And there's my needle, hair ice on the piece of wood. And there's my ice flower garden. Looks pretty motley. But if I take close-up photos of that, I now have an ice segregation garden. And I have my ice flowers. I have my needle ice in the soil. I have hair ice on a piece of dead wood. And I have pebble ice on a particular rock. I now appreciate and understand how ice segregation works at the surface. These plants, the soil, the pebbles, and the pieces of dead wood have pore spaces too small to prevent ice crystals pass through, but they're large enough to let water pass. So at a critical temperature, super cold water on the surface encounters a frost crystal, and we see the growth of ice. I'm thankful I've been able to explore so many occurrences of such interesting and beautiful ice. Then I get an email from a teacher in Cairns, Australia, 2017. This is northeastern Australia, near the Great Barrier Reef. It's in the tropics, where they do not see snow or freezing temperatures. And the teacher was involved in the Australian Children's Poetry website, Australian Children's Poetry. Teacher is Celia Barrow, and she worked on science rhymes and arguing that we can learn science through poetry. It's National Science Week, August. Schools and communities are celebrated with a myriad of science events, but they don't all need to be sensationally explosive or super techy. In fact, poetry can be perfect. Sharing snippets of science and poems is a great way to befriend physics, chemistry, and biology. And encouraging students to write their own poems helps focus their science understanding in a memorable way. And she sent me a copy of an article of a poem by Evie, Ice Flowers. Such complexity and beauty, in a simple form, but only cold conditions, winter or autumn. The sap in the stem escapes. Thin cracks will form. Then water is drawn. It touches the air. Ice petals will form. That is how an ice flower is born. Ravishing and rare, not found everywhere. Of course, green plants can create, yet also on wood, fence, or a gate. Where water comes through the gate's pores, the forces push this limited cause. So tempting to touch, but wait, don't rush. Ice flowers will break. Don't make the mistake. Instead, snap your lens with a longest keepsake. A lovely way to celebrate National Science Week. Evie, I think, is 10 years old, or was 10 years old. Her parents corresponded with me. I provided some photos that Evie could post on her site. And I conclude there. I leave you with 3 of my web pages as links if you want to pursue things. And I also provide the full reference to the log or bibliography and to the article of the 2 Japanese scientists who saw one Keiskea. And I leave it at that. Thank you.
All right. Any questions for Dr. Carter before we close? All right, Dr. Carter, thank you very much for being here with us today. We really appreciate it. So for next week, July 8th, we are very happy to have with us Dr. Lenetra Tate from NASA's Space Technology Mission Directorate, and she's going to be talking to us about the Mars 2020 mission. So definitely don't miss that. Registration for that will be up soon. And once again, thank you very much. If you'd like to support the museum, you can get us at support.smv.org or on PayPal. Once again, Dr. Carter, thank you so much for being here today. Thank you all for coming, and hope to see you next week for Dr. Tate from NASA.